Hello, David here on Davsportal. Before we begin, I would like to greet our friends from Russia. Прибываем русским друзьям и читателям Яденюш, что у вас високорошу сегодня. And also our friends from Indonesia. Hello teman-teman dan permisi Indonesia saya harap Anda semua baik-baik hari ini. And last our friends from India. मेरी भारतीय दोस्तों और दर्शकों को नमस्कार मुझे आशा है कि आप सब ठीक होंगे. So now we begin our topic. Today we will gonna discuss about the direction flow of refrigerant on a semi-hermetic refrigeration system. It is important, especially for beginners in refrigeration system, to know the direction flow of refrigerant, so that we could avoid mistakes, especially when replacing filter dryers or attaching manifold hose when doing charging or doing recoveries. For example, we will use the refrigerant R22. From evaporator, it will flow through the system via this cover tube inside this vapor barrier plastic. R22 then enters into this accumulator. The accumulator will accumulate partly vapor, partly liquid R22. This partly liquid gas will stay until it boils. Then and only then it will exit the accumulator and enters into the liquid and enters into this suction valve. From the suction valve, our partly vapor, partly liquid gas or refrigerant will enter into this semi-hermetic compressor, where it will compress, the compressor will compress our gas and turning into superheated partly vapor, partly liquid refrigerant. It will then exit into this discharge valve, flowing into this cover tube, and then it will enter into this oil separator. Inside the oil separator, the oil from the compressor mixed with our refrigerant. So the purpose of oil separator is to separate oil from our liquid refrigerant. Then after that, after it is being separated, it will flow into the copper and enters into the series of tubes, and we call this condenser. The condenser will then blow the superheated refrigerant using the motor fan, blowing the superheated and throwing the heat into the air, and then leaving the refrigerant with low temperature, high pressure liquid. Then enters into this liquid receiver, where it will be our staging area for our refrigerant. Then after that, it will exit again from this liquid receiver, flowing into this cover tube, enters into this pressure gauge and pressure switch, and then also it will flow into this cover tube again, enters into this filter dryer. The filter dryer will then filter our refrigerant from foreign objects such as dust and moistures. Then after it is being filtered, it will enter into the line of solenoid valve, wherein the solenoid valve will serve as the variable switch for our refrigerant to enter into the evaporator. We will gonna discuss later about the functions of solenoid valve, but for now we will focus on the flow of refrigerant into the system. The filter dryer has an indicator arrow for the technician to follow upon installation to avoid backflow of the refrigerants. As the refrigerant enters into the evaporator, usually all AC system has a thermal expansion valve. The TXVs are also considered as a variable switch to control the amount of gas entering into the evaporator. The TXVs has a sensing bulb attached near the exit line or pipe of evaporator. If the sensing bulb senses high temperature on the system, the TXVs will allow more refrigerant to enter into the evaporator. If the sensing bulb senses low temperature, the TXVs will minimize the amount of refrigerant into the evaporator. In the evaporator, the blowers dissipate the cool temperature of the room, replacing the warm air with cool air. Upon defrosting, most evaporators have built-in heating coil to speed up defrosting the flooded evaporator. Without the TXVs, refrigerant could flood out the evaporator and will eventually build too much ice on the coils and fins of evaporator, which in the end will cause a negative suction on the system. If the flooded gas gets into the compressor, it could damage the compressor because liquid cannot be compressed. The cycle goes on and on, repeating the process of compressing, condensing, and evaporating the refrigerant.